Hello and welcome to my virtual presentation. My name is Danielle Halsey, and today I'm going to share with you a project that myself and collaborators from the University of Delaware and Delaware State University developed to record the occurrence and distribution of species of concern in a future offshore wind energy area. Offshore wind development is projected to increase rapidly over the next decade. The Departments of Interior, Energy, and Commerce have announced a shared goal to deploy equipment with 30 gigawatts worth of offshore wind capacity in the United States EEZ by 2030, all the while protecting biodiversity and promoting co-use of the ocean. Our current capacity sits at just over 40 megawatts, meaning that wind turbine construction efforts will be ramping up rapidly in order to meet this 30 gigawatt target goal. Here are the current areas of approved or potential offshore wind project areas within the US EEZ. You can see that they are mainly concentrated along the East Coast. However, there are a few projects along the west coast of the US as well as offshore of Hawaii. In general, offshore wind projects around the globe are concentrated in relatively shallow nearshore waters, as you can see from this plot showing the distance to shore and water depth of installed and planned project locations. We can see that the planned projects for the US are slated to be pretty large, and because these projects often occur in nearshore coastal shelf waters, there's also the potential for these projects to interact with nearshore fisheries as well as species of concern. So today I'm going to present results from a study we conducted in one wind energy area along the mid-Atlantic coastal ocean. The Delaware Wind Energy Area is a leased area offshore of Delaware and Maryland, lying between the incoming and outgoing shipping lanes for the Delaware Bay. The closest point to shore is approximately 11 miles due east from Rehoboth Beach, Delaware. We deployed acoustic receivers along the perimeter of the Delaware Wind Energy Area to monitor the occurrence and distribution of tagged species in the area, which will help us inform future impact assessments and plans for construction. We partnered with a local commercial fisher, Mr. Wes Townsend, who commonly fishes in the area, and he was really helpful in informing our array and mooring design, as well as helping with equipment maintenance. In addition to our focal species, we leveraged collaborations with members of the Atlantic Cooperative Telemetry Network, which during the time of our study, the network consisted of researchers with over 7,000 active acoustic tags in individuals from around 90 different species, many of which occupy the US coastal ocean at some point throughout the year. However, for our study, we were particularly interested in two species of concern in the mid-Atlantic. The first focal species is the winter skate, a common shelfwater species within the northwestern Atlantic Ocean. The species is widely distributed, however, is commercially fished for by fishers using both bottom sink gill nets and bottom trawlers. And there's concern that offshore wind turbines may interfere with fisheries that use these fishing methods. Prior to our study, there were relatively few winter skate in our area, so we surgically implanted acoustic transmitters into 25 female and 25 male winter skate, which were captured in the coastal mid-Atlantic Ocean with the help of another commercial fisher partner, Mr. Kevin Wark. Our second species of concern is the Atlantic Sturgeon, a prehistoric anadromous fish, which is known to occur in the shallow estuaries and coastal waters along the US East Coast. These fish were heavily fished for in their spawning rivers in the late 1800s, and by the turn of the century, fishers and rowboats successfully overfished the population. Currently, Atlantic sturgeon populations are impacted by bycatch in commercial fisheries as well as ship strikes. This photo shows a sturgeon which was struck by a ship's propeller and thankfully recovered. However, that's often not the case. Additionally, because they return to their natal spawning rivers as adults to spawn, they are susceptible to disturbances from river channel dredging, urbanization around rivers, and salination issues. And coastal ocean offshore construction projects have the potential to impact these fish while they feed and migrate within the coastal ocean. So because these populations have remained relatively low despite a moratorium on commercial fisheries, Atlantic sturgeon have been federally listed as endangered in 4 of their 5 distinct population segments. These population segments relate to their natal spawning rivers of sturgeon and can be determined through genetics. However, sturgeon do not remain within their distinct population segments. These fish migrate long distances up and down the US Atlantic East Coast, so regardless of where they spawn, they're susceptible to disturbances and threats along the entire coast. Prior to our study, there were actually quite a few Atlantic sturgeon tagged with acoustic tags within the mid-Atlantic. However, we deployed an additional 50 acoustic tags in 18 female, 20 male, and 12 unknown Atlantic sturgeon captured in the coastal ocean off of Delaware at the same time that we were fishing for the winter skate. To sex Atlantic sturgeon, we used gonad tissue samples obtained while surgically implanting the tags, and unknown sturgeon are those for which gonad samples were not able to be obtained or not able to be identified. Our study lasted for 2 continuous years before most of the survey and construction activities related to future wind turbine projects were slated to occur in the area. Over those 2 years, we recorded over 120,000 detections on our receivers. In addition to the fish we had tagged, we also detected tagged individuals from 19 different species. Here I have plotted all of the species we detected, everything from bluefin tuna, white sharks, actually quite a number of different shark species. We detected striped bass and Atlantic sturgeon, and even a couple of marine mammals. However, the majority of the animals detected were either Atlantic sturgeon or striped bass, with hundreds of tagged individuals for each species detected by our array. Because we maintained the array continuously for 2 years, we were able to document the seasonal occurrence of species in this part of the ocean. Just with your eyes, you can probably start to pick out the seasonality in the occurrence of these species. A great example for this is the striped bass, which were more common in the winter and relatively absent in the summers. While interestingly, there was a surprising lack of seasonality in the occurrence of Atlantic sturgeon. To look at how use was distributed around a lease area throughout space and time, here I have plotted the cumulative number of detection days, or detections per individual, per receiver, per day across all species. In general, there were always tagged species in the array. However, some months had higher use than others. For example, you can see the larger circles in November and December indicating higher cumulative detection days. Out of the 50 winter skate tagged as part of this study, we only detected 13 individuals, pretty infrequently. Their occurrence was isolated to the spring, and then we had some detections in November and December. But because their occurrence was pretty limited, this is all that we're really going to be talking about winter skate for the sake of time today. Atlantic sturgeon, on the other hand, were detected almost every month of the year. We've recorded over 40,000 detections of 360 individual Atlantic sturgeon, which had been tagged either during our study or by our team for previous studies. Atlantic sturgeon seem to be concentrated in this northwestern corner of the array in the spring and the summer, which coincides with previous modeling work by Brees et al. For Atlantic sturgeon in the mid-Atlantic, which indicated that sturgeon are more likely to be found closer to shore in the spring. However, in the fall, sturgeon were more evenly distributed throughout the array and detected further offshore, more along that eastern line of receivers. This similarly coincides with previous modeling efforts, which predict sturgeon occurrence to shift offshore in the fall and winter. Unfortunately, however, previous modeling efforts did not extend into our study area, so we developed an additional regionally specific species distribution model from data collected during our study. So I matched the observations of Atlantic sturgeon presence and absence recorded by the acoustic receivers to environmental predictors and found that the model that best predicted sturgeon occurrence was a generalized additive model that included modeled bottom temperature, ocean color absorption at 443 nanometers, which is this color blue and likely related to ocean productivity, sediment grain size and bottom slope. These bottom type characteristics were fairly unique to be able to include in a model like this, but because this is a wind energy area, there had been previous geological studies done in the region and these data layers were available for me to use in model development. Finally, there was an interaction term between both bottom depth and sea surface temperature. This is a massively simplistic breakdown of the model, so please reach out to me afterwards for additional details. However, in summary, the GAM allowed us to make dynamic daily predictions of sturgeon occurrence, as well as monthly climatologies of occurrence for planning and permitting purposes. Cross-validation analysis revealed that this model correctly classifies 79% of sturgeon presences and 75% of sturgeon absences with an AUC value of 0.84. Monthly climatologies of predicted sturgeon occurrence throughout the entire lease area highlight some hotspots that may be really important for sturgeon where we didn't have acoustic receivers placed. Specifically, the northwest corner of the lease area had higher predicted occurrence than the rest of the array. While we don't know exactly what the sturgeon are doing here, this part of the lease area does contain an essential fish habitat, where many years ago retired New York subway cars were placed on the seafloor as artificial reef structures, which sturgeon may be attracted to. And additionally, in this corner, there is an ancient river channel visible in this 3D rendering showing the bathymetry in this region. In this channel, the sediment differs from much of the rest of the lease area and is likely related to the strong currents that flow through this bathymetric feature, which may be attractive for the sturgeon. Additionally, our model predicted highest occurrence of Atlantic sturgeon in November and December, with sturgeon distributed much more evenly throughout the lease area. So our results will be used by the Bureau of Ocean Energy Management to inform environmental impact assessments, permitting, and construction of planned wind projects in the area. While it is unclear how large of an impact wind turbines will have on Atlantic sturgeon or the other species that we detected in our array, we at least have a baseline of their occurrence that will help us detect any changes in the future. Currently, construction is planned for the southern portion of the wind energy area, but it remains to be seen how the construction and introduction of these structures will affect the ecosystem. So with that, I'd like to thank you for attending my talk, and I'll leave you with a rendering of what the current project is projected to look like for beachgoers in Delaware and Maryland. I would like to thank everyone who's helped in the field with fishing and deploying tags, recovering receivers. Additionally, I thank our funding source, the Bureau of Ocean Energy Management, and our other academic and data sharing partners. For more information, please feel free to email me or check out the full report for this project. Thank you.